So welcome to our turn mill machining demonstration. A bit about Tebis. Automotive focused OEM and Tier 1 suppliers. We've been more than 30 years in the industry. We apply world leading technology, quality, safety and efficiency. The objectives of this live demonstration to easily produce 3-axis and 3+2 toolpaths, combine milling and turning operations, import predefined manufacturing processes and verification and collision check using the virtual machine. Our tooling library and feature-based technology. We employ full form machine tools. We can link toolpath calculation to the virtual machine. We can link tool magazine libraries to the machine. We can link a real machine to the real tool magazine. We can program using material cutting data, centralization of tool library and local user libraries, no overcutting or undercutting using recommended material conditions. Templating strategy. Can automatically select elements for machining and NC programming with templates. Template technology with automatic and variable selection of data and cutters. Benefits include fast programming times, consistent quality, approved strategies, ruled and freeform feature technology, colour table machining, automotive colour scheme imports via CAD and NX. Programming virtual machine technology. Actual machine technology used in toolpath calculation. Virtual tool magazine with the tool libraries. Machine rotational limits. Macros and subroutines incorporated into the toolpaths. Macro control of rotational axes such as control over asymmetrical heads. Multiple setup machining with optimized tool change and cutting direction. And that includes collision detection with surrounding parts and fixtures. Machine tool simulation and toolpath validation. We can simulate tool changes, including the runtimes, simulate macro movements of the machine, so all of the movements that are off the tool. We can simulate all tool movements, including links between 5-axis tool paths and tool changes. And this incorporates accurate time calculation because of the use of the actual machine's internal kinematics. So here we have our demonstration of Tebis turn mill. As we can see on screen, we have our chamber component that we're going to be turning, and then what we're also going to be doing is milling this as well. In the left hand side we have our component tree, and what we have is things like our part data, our blank material and our clamping devices. So with Tebis, what we're going to do is we're going to open our programming process and we're going to use Tebis automation to create this program. So when we come into our program, what we can see is our programming operations already set out for us. So in this case we're going to use the main spindle and the lower turret. What we're going to do is we're going to use these smart toolpath templates. And smart toolpath templates are a set of predefined completely set up machining processes. When we apply these to a program, what Tebis will do is automatically draw the data it needs from the layer tree, add it into the programming operation and calculate the programming operation automatically. So our first operation will be to face the component. So we're going to choose a facing operation with the lower turret and apply that. So this operation now knows what tool it needs to use, knows the machine that it's supposed to be using, but doesn't know any of the components involved. So it doesn't know where the stock is, it doesn't know where the component is, and doesn't know where it's set in the machine. When we hit the calculate button, it will draw that information from the data tree and apply it automatically. What this means is that we understand how the tooling is working through our tooling library, we understand how the component is held in real space, and Tebis draws that information from within the layer structure. What this means is that by just dropping the operation into the program, we're able to create the program very, very quickly by having Tebis do all of the legwork for us. So with the exact same process in mind, we're then going to create a core drilling operation, but we're going to use the upper turret. So again, we copy and insert. Then all we have to do is calculate the toolpath. And Tebis has done exactly the same as it did a minute ago, which was to automatically select the geometry it needs, apply the tooling and apply the process. So then in an automated fashion, what we have is a core drilled operation using the head unit rather than using the lower turret. As we go through these processes, we have a number of predefined operations, and each of these will be applied to the program one by one until we get a complete program. As you'll see, in each of these operations, we have the same structure laid out, but as we get through this process, we're going to start seeing that these programs have already been applied, and they create the completed program. So when we come to OD roughing, we're going to rough with the lower turret, and again the geometry has already been automatically selected by Tebis, and also this toolpath is generated automatically, applying the correct speeds and feeds all the time. So we can see our trimming cut on the outside. We can then see undercutting to create the main form of the body. We can then see internal roughing. Tebis has automatically compensated the roughing path to the 50mm bore that we put into the middle, therefore minimising the amount of overcut and the amount of wasted time in toolpath. For every one of these operations, Tebis will justify the stock that's left from the previous operation, therefore minimising the amount of excess movement and the amount of excess toolpath. So similarly, these two operations were finishing the OD and finishing the ID. When we come down to this last group of operations, what we can see is we're going to start with some milling. What's quite important for Tebis is that Tebis makes no distinction whether we're milling or turning within a machine. If the machine is capable of using that operation, Tebis is able to apply it. So what we've got here is our milling operation. Now fundamentally what Tebis has done is it's justified the previous stock. As part of the feature recognition and part of the templating process, we have colour coded some areas of this part. Now what Tebis has done is it's used the main component for collision checking. It's machined up to the specified colour within the operation and justified that all against the existing stock. So what we have is a roughing operation that runs all the way around the outside of the component. Now if we were to look at this operation in the virtual machine, what we will notice is that the tool comes in, loads the tool up, and then obviously because we can't reach all the way across the component because of the kinematics of the machine, Tebis will automatically throw up a limit error and tell us that we can't travel any further. What this means is we need to convert this toolpath to a polar motion. So to convert it to a polar motion, all we need to do is add a machine configuration to say polar on, and of course one to say. So now when we come back to the virtual machine, what we can see is that Tebis will now create this operation but using a polar movement. So as the tool comes down, comes in from an accessible point on the component and does the machining it needs to do whilst rotating the component to get the movement that we need. So as I say, we go through the various operations including face grooving. So we're going to groove the internal face groove there. That's the roughing and the finishing to follow. We've got some internal diametric grooving, roughing and finishing. Then what we do is we come out to some external milling, and all of these operations have been applied exactly the same. What we haven't done is pre-calculate any of these or predefine any of these. These templates are literally drawn into the program, calculated. Tebis automatically draws the data that it needs and completes the program. What's very nice in Tebis is our feature recognition. So within one single operation, what we're able to do is do some feature recognition, which allows us to predefine certain machining operations and recognise them directly from the component. What that means is the pockets all the way around the outside of this component, and all of the holes around the outside of the component, and all of the holes in the front face of the component are all taken care of in 3 operations. This is regardless of the size, the variation in size, the depth, or the orientation of any of these features. So what we can see is Tebis quite happily running around creating each of these toolpaths as we go. So what we've got is a multiple of operations, roughing, side finishing, base finishing, all with a variety of tools, all going through this particular component and creating all of the machined features that we need to see all in one hit. These are all collision checked and all completely safe. So what I've got in this next operation is a deburring operation. So this is our 5-axis deburring. So basically this will create axial movements and create a constant deburr around all of these features. What I've also included is a component transfer. Now the component transfer will automatically tally the dimensions from your first reference point in relation to the job to the reference point for the back half of the job, and create an automatic component transfer. This is an all-in-one operation where we just add the component in, and Tebis automatically takes care of the transfer of the component through the virtual machine and through the stated chucks. So in this instance, if we just have a quick look at this in the virtual machine, what we can see is Tebis rotate the machine head, jump into the tool carousel obviously, pick up our deburring tool, create the deburring operations around the top half of the component, so these are all created without there having a necessity for a full break edge or a particular contour. So Tebis is able to create these 5-axis break edges with very little information. Then what will happen is Tebis will decant the tool, push the head into a safe position, and then create the chuck transfer. We can see the chuck at the front half of the machine and the secondary chuck at the back half. And as the head goes into a safe position, the chuck comes in and retracts. Then Tebis goes away, switches tooling, and continues machining. All very simple, all very easy to use, all very intuitive. So with all the rest of these operations now instigated, what we have is some facing operations, we have some internal roughing for the back half of the component, we have some internal finishing, again we have face grooving for each area of the component, we have some internal roughing, some internal groove finishing. We then rough the flange off the front. Then we have some contour finishing with a polar activation. We have some features on the back to take care of the back holes. And then again we go into the deburring operations. So just to summarise what we've seen here today, we've done turning and milling all in one operation. We've used a primary head and a secondary turret. We've also used a primary chuck and a secondary chuck, all in one program. What we've done is we've used Tebis templating to create perfect scenarios. So we already know the operation that we want to use. We already know how we want to instigate it. And Tebis is able to take that operation, automatically select the data that it needs from the layer tree, automatically apply the correct tooling, and automatically apply the correct speeds, feeds, cut depths and cut widths to create the perfect finish. What this means is that with Tebis technology, we're able to work absolutely consistently, absolutely accurately, and absolutely safely. It means that no matter how many programmers you have on your team, or how many operations or types of work you're doing, and even regardless of which type of machine you're working in, we can guarantee process consistency. In summary, Tebis is an integrated CAD/CAM solution. We create seamless workflow and avoiding data transfer by working within one single piece of software. Milling and turning solutions are in one workflow. This means no switching of softwares, no switching of environments. Tebis works with this all in one place. Tooling library and feature-based technology. Tool collision detection, linked material cutting data, tool magazine control, and true form tool simulation. Template strategy technology, standardized manufacturing processes, fast programming times, consistent quality and color table recognition. The virtual machine technology, with over 15 years experience in virtual machine technology, use of the virtual machine at all three stages of the process. We can use it in planning, programming and verification and collision checking. We use actual technology used in toolpath calculation, collision detection, toolpath optimization, machine tool simulation and toolpath validation. We can set up verification, macro simulation, asymmetrical head control, accurate machining time estimates.